Good day, folks. In today's class, I'll be talking about finding the inverse of a matrix by using the Gauss-Jordan method. And I'm going to take an example here. Let's say matrix is given to me, that is 2, 4, minus 3, and then here minus 7. And I wanted to find the inverse of this matrix by using the Gauss-Jordan method. So first thing I will do is I'll multiply this matrices with the identity matrices. So this is 1, 0, 0. This is an identity matrix. And now what I'm going to try and do is I'm going to try and convert it into the identity matrix. And then whatever operation I'm going to apply on this or this one, I'm going to apply same operation on this matrix, and whatever the answer of that will be, means once I convert this into the identity matrix, and whatever this matrix will convert into, that will be the inverse of the given matrix. This is the given matrix and this will become the inverse of that. So let's start with the question. So the question one more time: 2, 4, minus 3 and minus 7. This is the question given to me. Now I'm gonna multiply it by 1001 here, and as I said, my objective is to convert this first one into the identity matrix. So what I'm gonna do is I'm gonna divide the row 1 with the 2, because identity matrix looks like 1001. That's how an identity matrix looks like. So I'm gonna say operation on R1, that will be R1 divided by 2. So R1, all the elements of R1 will be divided by 2, and minus 3 over 2, and then 1 over 2 here, and then 0 over 2, which is 0, and this will remain as it is, 4 and minus 7. All right, now this first element gonna become 1 minus 3 over 2, and this is 4 minus 7, and then 1 over 2, 0, and 0, 1. So I've converted the first element as the 1. Now what I'm gonna do is I'm gonna try and convert this element into 0. So this is the direction I'm gonna try and move it. So first element, then second element, then third element, then fourth element. That's what I'm gonna try and do. So whenever you have a 2 by 2 matrix, and you can also do it this way. So 1 times, and I'm going to apply the operation uh, R2. On R2 I will apply the operation R2 equal to R2 minus 4 times R1. So this one will be, first row will remain the same. So 4 minus, I'm going to write down 4 minus 1 time 4, and here for the second element minus 7 minus, and this is minus 3 over 2 multiplied by 4, and same thing I have to apply on the second one also. This is 1 half, and this is 0, 0 minus 4 times 1 half, and this is 1 minus 4 times 0. Now let's see what we're gonna get from here. So 1, this will become 0, this is minus 3 over 2, and this is minus 7, this is gonna become 2 here, and minus 3 times this will become minus 6, and now on here 1 over 2, and this is gonna become minus 2, 0, and minus, well, this will become 1, because don't make this mistake of 1 minus 4. So this will be 4 times 0 first, so which is 0. So this is going to become 1 here. All right, so in the next step, I'm going to compile it. 3 over 2, 0, minus 7 plus 6, which is minus 1. And then this will be 1 over 2, minus 2, 0, and 1. See how many steps I'm doing to just to perform one operation. So I'll highly encourage you guys to also give you guys enough space and enough number of steps so that you do not make any mistake. Now what I'm going to do is I'm going to multiply r2 with with a -1. Remember, what did I tell you? I'm going to move in this direction first, second, third, fourth. That's how I'm moving. This I wanted to convert it into 1 because identity matrix looks like 1 1 0 1. So these two I've achieved. Now I wanted to convert this one into 1. So R2 with -1. So if I multiply R2 with -1, 1 minus 3 over 2, 1 times 0 times 0 times -1, here minus 1 times -1, and here it will be 1 over 2. This is minus 2 times -1, 0, and my 1 times -1. All right, so this will become 1, 0, minus 3 over 2. This will be 1. And then this is 1 over 2. This is 2. This is 0. This is -1. All right, we got these numbers. And now the final step, I wanted to convert this one. So what I'm going to do is I'm going to say operation on R1, which is R1 minus 3 over 2 or plus 3 over 2 times R2. Because by adding, this number is a negative number, this is a positive number, so by adding we can solve it too. So 1, this will be 0, this will be 1, this is going to become 0, because I'll show you here, minus 3 over 2 minus plus 3 over 2 times 1. This is going to minus 3 over 2 and plus 3 over 2, which gonna become 0. Okay, and now down here this will be 1 over 2. This is uh, 2 times I have to multiply. This is 2. This will remain as -1 because I'm applying the operation on R1. So 1 over 2 plus 3 over 2 times 2, and here for the second element, 0 plus 3 over 2 times -1. And now I will compile the result, 1 0 1 0, and this will become 1 over 2, and this I will keep it in the bottom, so that I don't have any problem while solving the fractions. 3 times 2 is 6, so 3 over 6 over 2, and this will become 3 minus 3 over 2, and 2 minus 1, and one more step, 1 0 0 1. See, I am writing this one all the time with my work. Do not skip the steps. Do not just focus on solving this and don't skip these steps. Okay, otherwise I'll have to deduct marks. So this will become 7 over 2 minus 3 over 2, 2 and -1. So that's how you're gonna simplify. So this becomes the inverse of the given matrix. So hopefully you were able to understand how to find the inverse of a given matrix using the Gauss-Jordan method, and always follow these steps starting from the first one. First of all, try to make the first element as 1, then try to make this element as 0, then try to make this element as 1, and try to make this element as 0. So always move in this format so that you do not make any mistakes. So I'll see you with another video. Till then, goodbye.